Statelessness is a core architectural constraint for all REST-based systems. What this means is that REST clients are responsible for maintaining all of their own state as they proceed through their transaction. For example, a REST client wouldn't ask the server for the next result. They would say instead, give me the 9th result for this particular query. And in that way, the request encapsulates both which result they want and what the query is. It doesn't rely on the server having to know what those parameters are. This is important because it makes REST-based servers much easier to scale and enables caching and server switching in a way that wouldn't otherwise be possible. Now, this might seem confusing because obviously REST-based services need to maintain all kinds of state. Every resource is itself state-dependent data. And it turns out there are two types of state. There's resource state and there's application state. And while resource state is totally fine to maintain on the server, clients need to maintain application state themselves. So when you're designing REST-based systems, it's important to distinguish between resource state and application state. The main way that REST-based systems enable statelessness is through a property called connectedness, which leverages the self-descriptive nature of REST-based representations to enable those representations to describe the actions that can make sense for that representation going forward. For example, if you use the GitHub REST API to create a new project, the response could simply be 200 and an empty body. But a better representation that leverages connectedness would return a body that would have all of the details about what you could do with that repository now that it's created. For instance, there'd be links to the issues for the repository, the stars for the repository, the watchers for the repository. And in that way, all of these extra details would help connect that object to the rest of the representations within the back end. At the same time, this representation would still manage to hide other implementation details. So it's important that you don't return data that leaks information about your implementation, but instead just connects a resource to the other resources within your system. Although API are forever, every successful system really needs to evolve their APIs over time. In REST-based systems, we do this through a process known as versioning. One key reason why we want to version our APIs is so that we don't break existing clients. Fortunately, in the REST space, we have many different ways to version our APIs, but we'll talk about 3 of them concretely now. The simplest way to version an API is to just build it into the URI explicitly. So here we have v2/users. That's version 2 of our users API. If we created version 3, we'd have v3/users. And as long as we still responded appropriately to the v2 users endpoint, the clients would not be affected by adding the new version. Another way is to build it into the query. So here we're saying users/v equals 2. So we append the version as a query parameter. And that's another way, really similar to we're doing it with a path. Finally, we can actually augment the header itself. So here we're saying API version :2. We're adding the version number explicitly into the header. The nice thing about this approach is we don't have to change any client code at all if we add a new version. Another common task for REST-based services is authentication. Authentication is important for these services because they're typically running remote, and you want to make sure that the user who's making the API requests are actually authorized to do so. Authentication is also a really nice way to keep track of per-user access limits as well. For instance, if an API user can make 1,000 requests an hour, you can enforce this by forcing them to authenticate their API usage with your service. One easy way to perform authentication is using HTTP basic authentication over HTTPS. This basic authentication approach is supported by many different platforms. Alternatively, you can use cookies to track your authenticated users. Finally, the most common approach is to use a token-based authentication system, such as OAuth or OAuth 2. REST-based services provide the opportunity to collect all kinds of useful analytics about how your APIs are being used. For instance, by instrumenting your APIs, you can find out what the average response time for your APIs are, what your most popular APIs are, which of your APIs have the highest error rates. You can also instrument your specific users if they've been authenticated. Which users use the most requests? Which users use the fewest? Should you have pricing tiers that differentiate one set of users from another based on their usage? All of these questions you can answer by providing analytics on top of your APIs. The design concerns we talked about previously in terms of general purpose APIs also apply to REST APIs. Your REST APIs should be small. They should do one thing well, and they shouldn't leak their internal implementation details. Also, you should consider their usability so that clients can use them effectively. Just because REST APIs seem simple, it is important not to underestimate the difficulty associated with building a complex, long-lived REST-based system. When you're designing your systems, it's important to think about both their flexibility and their documentation. By designing a flexible API, you make it so your API can be used by many different clients in many different ways. This increases the flexibility for the clients and also makes it easier for you to make back-end changes without impacting those clients unduly. In terms of documentation, since REST APIs seem relatively limited, since you're just using an access method and a URI, you need to provide really good documentation. The documentation should often include examples that show how the API should be used and what sample return documents look like. This will make it a lot easier for your clients to use your API effectively.